Okay, 365 days. Wow, this is the last day in 2025, 31st December 2025. First, I want to say a very, very big thank you to you because without you, there is no me on this other side. I want to say thank you to every one of you that have subscribed to my channel, giving me your thumbs up, and your comment. I am very, very grateful. But if you still want to support me, my account is scrolling at the bottom because it takes a lot for me to remain on this social media. And next year, I have a lot to bring to you. I'm going to look at mathematics, I'm going to look at C++, and I'm also going to look at data structure and algorithm. What was my theme for this year? The theme was what? Manifestation in reality using programming as a guide. Now, because of that, I'm going to use this last program to wrap up everything that I've been teaching you, right? So without wasting much of your time, let's get right in. So I call it Final Synthesis 2025. So what is the whole goal of this program? It's just to illustrate or to show you the concept of the memory, which is one side, which is the hardware, and the other side, which is what? The software. Now, what is between them is what? The operating system. Now, the last few classes I've been teaching memory layout. So I'm just going to do that here. Now, this part, this part, this part, this is the stack. So I call this one command line argument. I will call this environment variable. So let's just do that. Then I have the heap. I have data segment, and then this is the code slash text segment. Now this data segment divided into two, right? Initialize and uninitialize data segment. So let's just leave it at this and then use this to explain the whole concept. All right. So if you look at this program, this part is, we are looking at this in terms of the hardware. Now on the part of the hardware, we have the CPU, we have the memory, right? Then we have the console, probably your screen. But on the part of the software, we have the compiler, we have the assembler, and we have the linker, right? Now, when I write this source code, I am the programmer. I write this source code. I will give it to the compiler. The compiler will convert this through the help of the assembler and the linker. It will convert this to what? To machine code, which is what? 0 and 1. But the CPU does not know that one. The memory does not know that. The compiler does not know the memory. The compiler does not know the CPU. So how do they interact? The guy between this software part and the hardware part is the operating system. So the operating system has one leg in the software part and one leg in the hardware part, right? So that's what I want to explain using this code. Now, in the software part, at the point of the linker, where the compiler has taken this and has converted it into the what? Into the memory layout. The linker will create this, right, as a layout on the part of the software. Now, the operating system will also create this in the memory on the part of the hardware. So it is the operating system that is mapping the software to the hardware. I need you to understand that. So let's use this program to explain all these concepts. Now, this is my preprocessor directive. This part does not have any business with the CPU or the memory. This is simply telling the compiler, I will depend on the tools that will be provided by what? That by the operating system, right? So the things I will need, some of them are here. The printf function. The printf is here, and then this malloc is here, right? Now I have my integer g assigned 5. If you look at this part, using my concept of spirit, soul, and body, in my next lecture, which is what I'm going to do next year, mathematics, programming, which is C++, and then data structure and algorithm, you will understand this fully. Now, if you look at this 5 represents mathematics, which means the spiritual realm. In itself, it's just a symbol. It doesn't have any meaning. But moving down to the soul realm, right? This G is giving it identity. Then you get down to the body form, where you are creating the body. So that is determined by what? The integer, the data type. That will tell you the size that will be allocated in the memory. Now, this will be stored in the memory, which is what? The initialized part of the data segment. This. Now, all these things will be done before this guy. So just stay with me. This will be stored in the data segment. The operating system will store it in this data segment. Then static int s. This is another variable s, but it has no value assigned to it. So it's going to be stored in the uninitialized part of the data segment, known as the .bss. Now, in religion, this can be seen as Christianity, to be precise, can be seen as the Christ point, being born again. Uninitialized data segment. No one comes to the Father except through me, which means in physics, this is referred to as a quantum field. So this is the point of zero potential, right? This. So the operating system will initialize this to what? To 0 in the what? Uninitialized data segment, because it cannot be garbage value. All right. So this is your test, which is a function. This function contains all this. So this is the action part. It will be stored in the what? In the text segment. Then we have the main. This should be right under this place, but because you can't see it, that's why I'm writing it here. So this main will also be what? Stored in the text segment. Now, all what I have explained to you, we have not entered into time yet. Right? This is before time. Now, the moment the operating system will create the process for this source code. Now, at the point of the machine, still before the operating system, the compiler, this one, the compiler will not include it. The compiler will only tell the OS, I will need a space for this guy, but that will be later in the program. That is the conversation. So now, everything has been set by the operating system. The process for this source code has been created. So that is the guy that is going to act. Now it will be loaded. Then control will be given to what? Main. So this guy will be loaded into stack, which is this place. This is the point of action. So this is the place of action, right? This is the place of action, the stack. So meaning physical world, daily activities. Now, when you enter into the stack, so on the part of before the operating system, this memory layout has been created. The stack is upward. That is, the stack is upward. So this main is stack. That's why they call it stack. Comes in. But on this other side of the hardware, after the operating system, this stack is growing downward, which means the higher memory, because this is higher memory, this is lower memory. So this stack is in the higher memory. So this main is taken to the higher memory. Then when you go in, you will see this text as a function. And then you will copy it again into the stack. On this side, it is taken in on top of this main, right? The text frame will be created on top of the main. But on this side, after the operating system, which is the side of the hardware, this text is going in to the next lower memory. So the higher memory is what? The main. So which is what? Inside the stack. So then the text will be created. Now, when the text is created inside this main, that is inside this stack, the frame for this text is created. It is then that all these activities will start. Then this variable will be created inside that stack frame, inside this text. That is this text frame in the stack. This will be created, and 10 will be assigned to it. And the memory size will be what? Integer, which is what? 4 bytes. Then it will get to this next line. This next line is calling this malloc, which is a function. This will go to the operating system. The operating system in the case of Microsoft is divided into two parts, kernel and shell. The kernel is the back end, the shell is the front end. Now the back end is the part doing this job. So it will tell the operating system, I need you to allocate memory for me. And what is the size of memory? Integer, which is just what? 4 bytes. Once the operating system does that, it will now send the address, right? The address of that allocation will be stored inside this pointer. Then this line is to check if the address was actually created. So if memory was created, then this part, nothing will happen. It will come to this place. But if it failed to assign memory to it, then it will return this error. Memory allocation failed, to print it out on the screen. Because it is void, it's not going to return anything. That's why it's not returning 1 or 0. I can write it in another way by changing this one to integer and make you return a value, right? Okay, so if there's an error, meaning memory was not allocated, it will print out memory allocation failed. But assuming memory was created, allocated, then you now come to this point and assign 99 to that memory using this pointer, right? Then you will come inside this place and you print out everything on the screen. So printf, we are calling this function. It will print out x10. This is a string literal. So x10. This %d tells you is a process expecting the value /n. So for this %d, it is this g. So x10 will print out 5. Then this is a new line. It will bring this static to the bottom. It will print out static. Assign. So this one will be what? That is equals to %d will take the value that is here. Now, there was no value initially, but the operating system will set it to what? To 0, because it cannot be garbage value. In what? In this data segment. That is like the memory of the soul. Then x, this auto, x is inside this function. So the moment you enter into this function, this memory space will be created and 10 will be assigned to it, so you to print it out. Then it will come to this place, this pointer, it will go to the memory space and print out the value that is inside. So the value will be what? 99. Then it will free this P, meaning it will free this memory that was allocated through malloc. If it doesn't free it, it will cause memory overflow, right? So this is like saying you've used the physical body to function on Earth, and then when you are done with your entire process, you will drop it. It will go back to the soil, and then you will return back to wherever it is that you came from, right? So that is the concept. That is the concept you are looking at. So then it will print out this value, and it will exit, come back to main, and main will return back to what? To the operating system, stating that I have executed all my function, executed the entire process without any error. So that is how this is going to work. So that is what I want to show you in this class. So I have been able to show you manifestation in reality using programming as a guide. The process might look so simple, but you can imagine the entire steps that you have to go through in order to manifest thought in reality. There are a lot to follow. So in the next year, my next project will be what? Mathematics, C++, data structure and algorithm. Now, why am I teaching you mathematics? I have taught you Python, and I've also taught you C. So C is closer to the hardware than Python. So Python is object-oriented, closer to human, looking at the point of abstraction. So C++ will come in between them, one leg in C and one leg in object-oriented, like Python. Why am I bringing in mathematics? Because it is actually the language that guides all of them, just like the operating system. And then data structure and algorithm is where these data are going to live. And then the algorithm is the step-by-step process that acts on those data. So when we are done with all this, then we can now start creating. That is my goal. So thank you once again. Thank you for being there for me. So next year, we'll begin this new series. Happy New Year in advance, and God bless you all. I love you. Should we go to code block so that I can demonstrate this for you to see? All right. This is our code block without wasting much time. This is the same code that you saw on the board. I am just going to execute it for you to see what the output will be. It will print out 5, 0, 10, and 99. Okay. Okay, so that is that. That is it. Extern is 5, static is 0. The operating system converted it to 0. It cannot be garbage value. Auto is 10. Dynamic is what? 99. Now, this static, this is what most of you see and call heaven, a place of consciousness, right? And in physics, is termed as the quantum field. So, it's a place of zero potential. Anything can come out from it. It contains anything. So that's what I want to show you this year. Next year, we'll begin a new series. Thank you so much. Thank you so much. And thank you so much for your support. So, Happy New Year in advance. Bye-bye.